Hey guys, welcome back. We are on page 87 and we're going to do the free response. So you should be comfortable with 2 of the 4. And I'm going to do the first one here. Now I've just kind of put some paper over here so I can write on it, because you should be doing these problems on a separate sheet of paper. So our free response question says, you're interested in how many contacts older adults have in their smartphones. Here are data on a number of contacts for a random sample of 30 elderly adults with smartphones. Construct a histogram. So in class, we had a chance to go over that. Are there any outliers in class? We did go over this as well. We're going to take quarter 1 minus that and quarter 3 plus this in order to figure out if we have either a high outlier or a low outlier, right? And we're going to answer the question, would it be better to use a mean and standard deviation or a median and IQR to describe the center? So really this is asking, is it skewed? So if it is skewed, we're going to use median and IQR. If it's not skewed, we're going to use mean and standard deviation. Okay? Yeah, so let's do it. So our numbers range from 7 to 151. Okay, so 7. $30, $40, $50, $60, $70, $80, $90, $100, $110, $120, $130, $140, $150. Okay? Well, and I guess that's going to be so. So let's look at our data. So it looks like 7 would fit between just 1, 0, and 20. In the next bin, we have 20 all the way up to just shy of 40. So it looks like we have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers there. 1, 2, 3, 4, 5, 6, 7, 8, 9. 42. The next bin, 42, 40 all the way to just shy of 59. It looks like I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers there. All right. And then 60 to just shy of 80 would be these 5 numbers. Right. And then 80 to just shy of 100 would be these 3 numbers. And then 135 would fall in here. And 151 would fall in here. Okay, so it says construct a histogram. I can't get full credit unless I label my graphs. So this is number of contacts in the cell phone. Okay. Now, this looks relatively-ish uniformy, but we've definitely got some outliers here. So I think our answer to C is we're already feeling like we want to say we like the median and the mean better, right? So A is done. We constructed it, right? B, I'm kind of going backwards just because I wanted to be able to see my problem here. Are there any outliers? Sure, let's figure it out. So we have to find the middle, and it says it's 30 people, so half of 30 is 15. All right, so we're going to count 10, 11, 12, 13, 14, 15. And so that number right there 13, 14, 15. So that's the median. So the median is 46.5. And so we have 15, and we can cut that in half, and we get 7.5. So we're going to count in 7. 1, 2, 3, 4, 5, 6, 7. And then our 8th one, and then you should have 7 again. 1, 2, 3, 4, 5, 6, 7. So this is quarter 1. And we'll do the same to the top. I can count down 1, 2, 3, 4, 5, 6, 7. And that would be my quarter 3. So too low would be something smaller than quarter 1, take away 1.5 IQR. So 30, take away 1.5 times 44. And I don't have any negative numbers, right? So I should be fine there. All right, so what about too high? High would be any number bigger than quarter 3 plus 1.5 IQR, right? So quarter 3 we said is 77 plus, we already said 1.5 IQR with 66. So 66, 77 plus 66 is 143. So as we look here, we only have one outlier. And they want to know why, and it's because 151 is greater than 143. It says justify your answer. All right, last one. Which one would be better? And we're going to say C. And we're going to restate the question, right? The median and IQR would be a better measure of center and variability because, so we give our decision and we give our reason. The reason is because this distribution of, we want our contacts, right? Number of contacts is skewed right. And has a high outlier. So if you like this question, be ready to answer a question just like this, but with context and data slightly changed. Okay, now we're going to look at number 12. It says, a study among the Pima Indians of Arizona investigated the relationship between a mother's diabetic status, okay, so whether the mom was diabetic, pre-diabetic, or not diabetic, okay? And then we also ask, so this is obviously categorical data. We have to ask, are you diabetic, pre-diabetic, or non-diabetic? And it is a yes or no, right? And then here, the number of birth defects, right? Whether they had one, no birth defects, or at least one birth defect, okay? And that's a yes or no, isn't it? Yes, you were free of birth defects, or no. Yes, you had at least one. What proportion of women in this study had a child with one or more birth defect? Okay, so if I have to come up with a proportion, I need some totals here, right? So let's go ahead and fill in our totals. It looks like in total that'd be 40, 53, right? All right, let's get our grand totals. get 1,207. I'm going to double check my math. All right. Now it says, what proportion of the women in the study had a child with one or more birth defects? Of the people in the study, so that means out of the whole number of people in the study, what proportion said yes, you got one or more birth defects? So for A, I have 53 out of 1207. All right. And I can leave it like this, or I can turn it into a decimal. It didn't ask for percent, it asked for proportion. So it would make sense for me to leave my answer like this, or show this and turn it into a decimal. All right, question B, what percent of women in the study were diabetic or pre-diabetic? So if I think about this, we're diabetic, and it says of the women in the study. So once again, I know that I'm going to have the denominator of all the women that were in the study, the grand total. We're diabetic or pre-diabetic. So we're diabetic, well, there were 47, or pre-diabetic. Okay, so they want everyone except the non-diabetic had some type of a diabetic system. So I'm adding these numbers, right? And totaling that up. Oh, wait, I stopped reading, didn't I? Diabetic or pre-diabetic and had a child with one or more birth defect. Okay, so we're diabetic or pre-diabetic and had one of these birth defects, right? So that was diabetic or pre-diabetic and had a birth defect of some sort. So I'm adding this number. And I'm getting this decimal. And they asked for percent. So I'm going to actually turn that into a percent by moving the decimal twice. All right, the question continues on the next page. So we're gonna scroll to the next page. It says C, make a segmented bar graph to display the distribution of the number of birth defects for women with each of the 3 diabetic statuses. Okay. So I'm going to have to make some type of a bar graph, right, for each of the 3 statuses. So that means I had the non-diabetics, the pre-diabetics, and the regular old diabetics, okay? And I want to make a segmented bar graph, meaning that this side is going to go all the way up to 100%. Okay. Now I go back to my information, right? And I'm going to turn these into percentages. So showing my work here. I want to know the percentage out of all of the non-diabetics. What percent said none? So I'm going to do 754 out of 785. 0.96. Now, I could think this is going to have to be 0.04, but I'll just double check my work. So that means 31 out of 785. Beautiful. And I got 0.4. Now we're going to do the same thing again. I'm going to take that number and take it out of what's the percent of the pre-diabetics. So that's this number. 0.97, so that one's going to be a little lower, right? 0.03, double checking, 13 divided by 375. Yep, 0.03. And the last one, 38 out of the 47. 38 out of the 47, 0.81, right? Which means this would be 0.20. Okay. Now I'm going to take a snapshot of these so that I can transfer this information on the other page. All right, so I'm using this information to fill in my chart. So it looks like I'm going to go all the way up to 96%. And then I guess I'll show you this. And that means no birth defects, because this is no birth defects. And this is yes, at least one birth defect. All right, and the little sliver of the 4% more is what's left, right? All right. Now looking at the pre-diabetics, this chart looks very, very, very similar. It just looks like slightly more and slightly less green, just a smidgen more orange. All right, and then this last one, it's 20%, so that's quite a big difference. 20% on the top, so I'm going to go up here to 80. Leaving 20% and shade it in. All right, that was C. Now it says D, describe the nature of the association. So between these two categorical variables we analyzed, right? So we can say that if we were just analyzing these two, we could say there is no association or almost no association because this data is almost identical. But here, since the data does look different as we compare all three, or we compare this one to these, we notice that there is an association, okay? So we have to go for it and state what we mean. We have to say, first off, there is an association between the two categorical variables that we assessed. What were those? Remember, we assessed the diabetic status, and we assessed the number of birth defects. All right. Now we have to say why we think that, right? And we can say just like we said, the first two bar graphs, the non-diabetic and the pre-diabetic, appear to have birth defects at a similar rate. Right? At around 96, 97%. However, women with diabetes, this category, right, have a much higher rate of birth defects. When we look at this, if you were a mother and you were saying here, well, what are my chances of a birth defect? And you're saying, well, at this reservation, only about 3 or 4% of people have birth defects. You're like, oh, okay, I don't like my chances. But imagine if you were diabetic, your doctor would be saying, well, because you're, or maybe they won't say because, but they'll say, because I know that you're a diabetic, I can tell you that your chances of a birth defect, having a baby with a birth defect, is 20% likely. That's a huge difference. That's 5% more likely, maybe even more than 5% more likely. All right, check out the next video for the other 2 free response questions.